Pascal's triangle is a triangular array of numbers that holds so many mathematical patterns and relationships among its entries. The triangle is named after a French mathematician, Blaise Pascal, who worked a lot with the triangle in the 1600s. Even though the triangle is named after him, he was not the first person to use the triangle. We saw uses of the triangle in ancient China between the 12th and 13th centuries. We also saw it in Persia in the 13th century as well. Heck, in Asia and Persia, it's not even called Pascal's triangle. But Pascal's the one who gets the credit for it. I wonder why. Anyways, Pascal wrote this big math book that talked a lot about the triangle. It introduced many uses of it that weren't really known to people. So he did contribute a lot, and it's not like he did nothing. So something that we need to know about Pascal's triangle is that a lot of times this single one at the top here, instead of being called row 1, that is actually in fact called row 0. Not row 1, that is row 0. So a pretty cool thing about Pascal's triangle that a lot of people don't know about is its ability to be used when we want to solve combinations. Now this is the standard formula for combinations, n factorial over r factorial times n minus r factorial. So say our question is we want to choose two possible things from a set of three total things and see how many combinations are possible. If we want to do that, we plug in 3 for n because n represents how many total things we have, and 2 for r because r represents how many things we want to pick. When we plug that into the formula, we get a total of 3 possible combinations. What's pretty cool about Pascal's triangle is that we can kind of ignore the combination formula. If we want to see how many total combinations are possible when dealing with something like this, all we have to do is simply look at entries in rows of the triangles, and we find the exact same answer as plugging in the formula. So say we want to if we want to see how many combinations are possible when choosing r things from a set of n total things, we simply look at the rth entry in the nth row. So for example, if we go back to our example, if you want to if we want to choose two things from a set of three total things, all we do is look at the second entry in row 3. Now if we go up to our triangle and we look at row 3, which is this one right here, the 1, 3, 3, and 1, and we look at the second entry, we see that we get 3. And we can see that that is the exact same answer when we plug it in. So when we're dealing with combinations and we want to know how many combinations are possible when choosing r things from a set of n, we simply look at the rth entry in the nth row. So the last pattern that I'm going to show you is called rectangular sums. So in order to see this pattern, we kind of have to manipulate the triangle a little bit. We have to draw it as a rectangle. The way you do this is you take the first diagonal of the triangle and turn it into the first row of the rectangle. Take the second diagonal of the triangle, turn it into the second row. So you see that the first row of the rectangle is the same as the first diagonal of the triangle. It's all the ones. The second row is the same as the second diagonal of the triangle. It's all the counting numbers. Third row is same as the third diagonal of the triangle. It is all the triangular numbers. So here is the theory of rectangular sums. All you do is you draw a box around any number inside the rectangle. You then start at the top left corner of that box and extend the line up and to the left so that it creates a rectangle around a bunch of numbers. All of the numbers inside this rectangle will sum up to 1 less than the number inside the box. Let's do an example of 10. We draw a box around 10. We start at the top left corner of the box. We extend the line up and to the left, such that it creates kind of a triangle around the numbers 1, 1, 1, 1, 2, and 3. Now, if we sum up these numbers, 1 plus 1 plus 1 plus 1 plus 2 plus 3, that comes out to a sum of 9. 9 is 1 less than 10. So again, the theory of rectangular sums is draw a rectangle around draw a box around any number inside the square. If you extend from the top left corner up and to the left, all of the numbers inside of the rectangle will be 1 less than the number inside the box. That is the end of the video. Thank you very much for watching.